Hello everyone, my name is Nguyễn Ngọc Thầy. I'm called 26 from Fulbright University, Vietnam. This video is about my project on simulating a chess clock on CircuitVerse. This project will cover three main concepts such as truth table, state diagram, and finite state machine. Since chess is a game of strategy and intellect, it has led to the development of various tools to enhance the competitive experience. Among these tools, the chess clock stands out as an essential component, regulating the pace of play and ensuring fair competitions. This project aimed to design and simulate a digital chess clock on CircuitVerse, which is a platform for designing and simulating electronic circuits. The proposed chess clock features a straightforward and user-friendly interface with two primary buttons, the run button and the switch button, allowing effective countdown management for each player. To enhance visibility and usability, the clock includes two 7-segment LEDs. This LED displays the remaining time for each player in a clear and easily readable decimal format. For the purpose of simulation and demonstration, each player's initial time is set to 3 seconds. This allows to quick test and showcase the clock functionality without the need for the standard durations of 30, 20, or 15 minutes typically used in an actual chess game. About the product design, this chess clock has two input and two output. Two inputs are the one with run button and one with switch button. The run button starts the countdown for the current player, while the switch button switches the active player, pausing the clock and starting the opponent clock. There are two outputs, which are two LED to show the remaining time of two players in decimal format. About the product operation, the initial time for each player for each game is set to 3 seconds. From here we set the run button to R and switch button to S. The game begins when R equals to 1. This starts a player countdown timer based on the status of the switch button. The switch button toggles between two players. This ensures that only one player timer runs at any given time. If S equals to 1 and R equals to 1, the remaining time of player 2 will count down. If S equals to 0 and R equals to 1, the remaining time of player 1 will count down. The two 7-segment LEDs show each player remaining time. This display updates in real time, providing a clear and accurate readout of each player remaining time. The game ends when either player's timer reaches 0. At this point, both clocks will stop. To reset the clock for the new game, set R to 0. About the state diagram, this is a state diagram of the chess clock, which has 15 states. As you can see at the top of the figure, regardless of S, when R equals to 0, the state remains the same. Otherwise, when R equals to 1, different value of S will lead to the decrease in time for different players. Additionally, the state also remains unchanged when either player timer reaches 0. Consider the 15th stage shown in the figure and the non-existent stage, which occur when the remaining time for both players is 0. We will have the binary modeling to encode this 16th state into 4-bit binary number. From the binary modeling and the state diagram, we will derive two truth tables. The first one is the state transition truth table, which has 6 inputs. The first four inputs represented by overline S3, S2, S1, S0 denote the current state, and the last two inputs are the run button and the switch button. Using this truth table and the 6-input K-math, we will obtain the four most simplified expressions for the normal S3, S2, S1, and S0, which represent the next state. The second truth table is the output truth table. The input to this table is the previous or the current state from the state transition truth table, and the output is A, B, C, D, E, F, G, which are the input for the 7-segment LED. We will also derive the most simplified expression for A, B, C, D, E, F, and G for each player. As you can see here, about the circuit design, there are 4 circuits to implement the interface of the chess clock. For convenience and to avoid the need to recreate the circuit when using it, each circuit is packed in a square subcircuit. First, let's discuss the gate-level circuit design for the output, based on the most simplified expression of A, B, C, D, E, F, and G for 2 players, derived from the output truth table. We observe a consistent pattern in these expressions. S3 and S1 occupy the same position in expressions as do the S2 and S0. Therefore, we can create a common circuit to display the remaining time for a player in the 7-segment LED. Secondly, let's discuss the gate-level circuit design for state transition by concluding with the most simplified expression from the 6-input K-math. This expression will help create the circuit for state transition. As you can see in this circuit, each output such as S3, S2, S1, and S0 is a combination of 6 inputs based on the sum of product canonical form. With this state transition circuit, when we input the previous or current state, we will obtain the next state as the output of this circuit. Thirdly, regarding the memory of the final state machine inside the chess clock, it has been decided to use the master-slave flip-flop. Finally, the state-level circuit design for the final state machine in the chess clock is a combination of 3 subcircuits: the output circuit, the state transition circuit, and the master-slave flip-flop. Since the state is represented by the 4-bit binary number S3, S2, S1, and 0, the final state machine needs to have 4 1-bit memory elements using master-slave flip-flop to store the state. This circuit also requires input value for run and switch. The output of this circuit will be the previous or current state of the chess clock, which will be displayed on a LED in the decimal format. Regarding the interface of the chess clock, here's how it appears on CircuitVerse. As mentioned in the product design, it will have 2 buttons, run and switch. In this simulation, to represent a toggle button, a 1-bit input is used. The output of the final state machine will be connected to 2 output subcircuits. S3 and S2 will be connected to the first output subcircuit to display the remaining time for player 1. S1 and S0 will be connected to the second output subcircuit to display the remaining time for player 2. Next is the live demo of the chess clock on CircuitVerse. We will demonstrate 3 cases. The first one is when the run button is set to 1 and the switch button is always 0. The second one is when the run button is set to 1 and the switch button is always set to 1. The third one is when the run button is set to 1. The switch button toggle to 0 only if player 2 turns in with 1 second or less remaining. Thank you for watching this video and hope that you have a nice day.